Welcome back to another video session. So, in continuation with my earlier videos, I wanted to discuss how for a given problem we can frame a logic and how we can have multiple implementations of that given logic. So in this video we will look primarily from the Python's perspective. We will see like how quickly we can write a solution to a problem if we have a better knowledge about the built-in functions in the Python, right? So let us first discuss the problem, and then we will discuss some alternate logic approaches to give a solution to this problem, and then we will see two variations of this solution to this problem. One which would absolutely not use any built-in Python function and which writes a logic by using the basic Python syntax and the basic programming constructs available in Python, and one which would rely on built-in functions of Python. So what does this problem do? So for you, quickly I'll read the problem. The problem is nothing but here I have already read this, so in short, in a very quickly I'll tell you what exactly this is. So you are given with an array of size n. So you are given a few numbers, and what exactly you need to do is you need to print the runner up. I mean here in other words, you are given with an array of numbers. You need to print the second max number in this array. So it's a usual. So a story has been made up to give you a twist to this problem. Like the participant score sheet for university sports, you are required to find runner up. As you all know that the first one is a prize winner and the subsequent one is the runner up. So they have given a sample input. The sample input is this, and the input is read like first they give you n and you need to read it, and you can see the output is 5 because the top scorer is 6 and 6 and the subsequent top scorer is 5, so that's why the 5 is the output. So I need to write a program to do this. So fairly simple, like, right? So if you think about 2 3 6 6 5, I think if I want to just roughly discuss the logic, I think we can discuss it here. Okay, so 2 3 5 5 6 was the input. So a quick approach would be to sort this array and find keep on exploring first index, second index. If second index is not same as first, then the second index would be the runner up, right? But the problem with sorting is that it would take slightly higher complexity of O of n log n, right? Because the best available sorting algorithm can't do best than O of n log n. But what we want even a better solution. So I don't think this is the best. This problem can be solved in O of n as well. So in O of n, what we do is we do the linear scan for that. Maybe what we will do is we'll maintain one element called as first and another variable called as runner up. So initially I'll initialize it to the minimum, whatever the minimum element for this array. Maybe for this let us suppose the minimum type of input allowed for this problem is 0. So initially I'll initialize them to 0 and 0, and then I'll keep on comparing. If it is greater than then I'll update that, and the runner up will be updated, right? So I'll keep the runner up as it is, and I move ahead, and if the element which is currently under the scan, if it is greater than existing one, then I update this. And before I update, so whenever I update first, what I do is I store this in runner up. So runner up will be from 0 to 2, it would be updated 2, and first will be 3, right? So on. If you go ahead with this logic, it works, but I think you need to take care that when you encounter this 5, from 3 you will be updating to 5, and from 2 this becomes 3, right? So if I just check the condition of greater than, I think we will also pass this out. will only update when it is greater than. So I'm not saying greater than or equal to, right? So if I just compare these two elements by greater than, fine, we will move ahead. And here is where we will come across this 6, wherein when I update this 6, so 6 is obviously greater than 5. So what I do is 5 would be here, and 6 would be the new first, right? Okay. So you can think of some another use case as well. So this is one use case, and if I think of some another use case, for example, if I take 2 3, if I take 6 6 5, right? So initially the first and the runner up, these two variables, initially they will be 0. So initially it will be 2, it would be 0. You will update from 2, it gets updated to 3, and this gets updated to 2. And when you are scanning further, so you scan 2, you scan 3, and when you are scanning 6, 6 is greater than 3, so it becomes 6. And whenever there is an update in first, before we update the first, we will store that earlier value in the runner up. So this becomes the runner up, and since it's a greater, that is fine. So you will be moving ahead. 6 greater than 6 will be false. Sorry, 6 greater than will be false. And when you go to the last element here, this is not greater, so 6 remains as it is, and runner up doesn't get updated, right? So look at this case. This is a very curious case. So here obviously the runner up should have been 5, right? The runner up should have been 5, but somehow our logic is missing that. So what you need to do is, even after you checking that, until and you reach to the end, though this element might not be greater than first element, but see if it is greater than runner up. Okay, so this is a case, it's like a corner case for this problem, a logically corner case. See if this element is greater than runner up but less than the first element. I mean, the first means the top first element. If it is so, then you update that. So we have figured out these two addition conditions. So based on tracing the logic based on this input 1 and this input 2, we can write this logic, right? So now if you figure out this logic, in this logic we are not relying on any built-in Python function. We are writing it in as a plain simple logic which will use on if and else, right? So we'll write that logic. So as we have said, we'll take a first and we'll take another variable called as runner up. We will initialize to the minimum possible element allowed. So what is the minimum possible element allowed to this? So you are given an n square and a of I can be from minus 100 to 100. So let us initialize it to a minus 101, right? Absolutely. So I am very sure that this value will never be a part of input. Okay, so once you are done with that, what you need to do is we need to just scan ahead, right? So in Python, how do we scan ahead? For each element in array. Okay, now you might ask me, so how is array? So remember, this function which has been provided as a built-in stub code for this problem, this ensures that you are reading this space separated lines, and this map with int of this, which ensures that this variable ARR contains all this n numbers of this array. So don't worry about that. Okay, so we will scan for each element in this array, and whenever we are scanning for each element of this array, we'll check if the element is greater than first. If it is greater than first, what we'll do is we'll update that, and whenever we are updating, what we'll do is we will first store the value of the top variable in runner up, and then we will modify the value of the first element, right? That was this for loop. Okay, and inside this, as I said, once you are scanning that, as I said, now we are coming back to this. See, this logic will work for this kind of input, right? But when I tried for this kind of use case, we found that this additional use case which I need to handle. So in order to handle this case, I need to write an additional if check. So what I need to check, if element is greater than runner up, as you said, what was the condition? The element greater than runner up but less than 6. In that case, don't update first but just update the runner up, right? Okay. So if element is greater than runner up and element is less than first, so if this is the case, then just update the runner up. Fine. Yes. So once you come out of this loop, your runner up would be the answer which this problem requires you to print, right? Okay, so let us see and let us submit the code and let us look at this. Okay, so sample test case is passed, and I think this is specifically a use case 2336665 for which we assess the second use case. The first use case was something we looked at sorted case, right? Okay, so now let me submit this entire code and let's see if all our test cases execute. Okay, you can see that all our test cases has passed. So you can see that this is a version of a code where I did not use any Python function. So if you look here, I almost 1 2 3 4 5 6. Now let me do a different operation. So what I'll do is, so I'll comment it. So for time being, I will commented this, and now instead of writing this, a logic where I have checked for this if conditions, multiple blocks. As I said, more the line of code you write, more the scope for errors, more the scope for bugs. So I was thinking, like, can we use any built-in Python function? So I can quickly tell you what exactly this Python function. So let us work in this same screen, right? So what I'm thinking of is let me make use of function called as max, count, and remove, right? So a max function, if you provide a list to this max function, it returns you the max element in this, right? And count, the count gives you number of times that element occurs in this array, right? So what I want to do is, initially I'll call max. So okay, so let me come back to this. Let me write this array 2 3 3 6 6 and 5. So what I was saying is, at first I'll call max. Let's say if this is L is equal to this list. So initially I'll call L, and what are the value I get? For example, this will be the first, right? And then I'll check the count of first. So count first, right? So now when I check the count of the first in the list, for example, in the list, if I check the count, and if it is equal to 1, then I'll call L dot remove first once. If it is twice, I'll call L dot remove twice. If it is 3, I'll call L dot remove thrice, right? So in this way, what's happening here is I'm trying to remove the topmost element and whatever the multiple occurrences of that element from this list. And once I remove that, and subsequent last max call in this list will give me the second topmost element in the list. So even this approach should work, but here I am relying on built-in functions of Python. So my focus here is to write less number of code. Okay, let us see that. Let us see if this code works on that. So one more thing was, I said this approach is a linear scan. Yes. So the complexity of this approach was O of n. So is the complexity of this approach O of n? Yes, because max does n scans, count does n scans, remove does n operations. It's almost an n operation, max n. So max, what you're doing is you're doing a 1 2 3 4 times n approx. And at the worst, if this entire array is made up of same elements 6 6 6 6 6 6 and that, only in that case this our core logic of counting and calling remove and that. So the worst case complexity of this will be O of n square, or else on an average this complexity will be O of n. So that's fine. But here we are relying on the Python's built-in function. So let us try this version of code where we will rely on the built-in functions of Python. So what I said is, I'll say the first is equal to max of array, right? I get that. And what I'll do is I'll check the count, or else I think I can so for I in range from 0 to count array in list. So I think count does take a second argument. So whatever times this count array returns, for that amount the for loop iterates. What I'll do is ARR dot remove I think since this being a map element, I need to say, so let me take some list underscore number. I want to be very specific, so I want to convert this. So the earlier object is it would be a generator object. So what I'll do is I'll convert that into list. My only conversion was the to list underscore num, and for I in range count, and this should be list dot num dot remove. So those times it works, and in the end I need to just print max from list underscore of numbers, right? And even this here should be list underscore numbers. So okay, so let us run it and see if our code executes. Okay, I think count. I think so. As I said, yes. So do not make these mistakes. As I said, whenever you encounter this such a mistakes, if I look in with respect to yesterday's session, this is a syntactic error. Like I wasn't much aware of what was exact the count, and maybe I have some error in this count function, right? So when you get this error, note down that okay, I was not able to remember how a count method in Python works, right? I knew that it counts the occurrence of number, but I wanted to know how many times it occurs and that. So I wasn't aware about what has to be passed. Either I need to pass this element or that, maybe something wrong with the return type. So this is a good indication that you need a good hands-on. You are still not that much comfortable to use the Python function. So let us do one thing. Let us check Python count. I think you can check it from Python docs. The best thing, go to Python. I think okay. So I think it's something called a list.count, and I felt on that. Yeah. So this happens when you work on multiple languages at the same time. I especially work with multiple languages multiple times. So list.count. Okay, so now, okay, as I said, what is a smart practice? Smart practicing: note down this mistake and do not repeat it. Note down this mistake and do not repeat it. The first thing whenever you want to practice any coding problem, right? Okay, so let me run this. Wow, okay, I think what it says, list dot remove. What was that? Okay, yes, this is what you have to develop a habit, that this is something you get it only by practicing. So mistake number 2, I did not make sure that removes argument was passed well. So 2 mistakes we made: unable to know the count syntax, and unable, so we didn't pass argument to this remove, right? So do not make these mistakes after whenever you practice further. So this is called a smart practicing. So this, okay, so now sample test case executed. Let me click on submit. In test case 0 is taking a time, maybe more number of n's, or yes, it executed, yes. So both our code executed well. So now what you see here is, as I said, this is something without using any built-in functions, which using built-in functions. So to be a better Python developer, as I said, rely on Python built-in functions, and there is no by heart any rule that you have to always remember that, but usually relying on built-in functions reduces your errors, right? So I think you should practice it with same pace and the same logic and the same way of writing a solution and then converting into a problem. So this will help you smartly practice instead of just blindly practicing hundreds of problems. Whenever you do a smart practicing, that always help you develop your problem solving skills step by step. That's it for this video.